Nikhil, I seen that there is community edition and the professional edition, both
Yes,
two editions are there.
community edition is free, and another one, I think professional, is the paid one.
Ah, yes.
So far we have completed. If I come at this point, we have gone through these labs. Today, the target is to complete MGRE and DMVPN. Basically the same thing.
Hmm.
So we'll have a look of how you configure your MGRE. Once we'll go with static NHRP plus IPsec, then we'll try with dynamic NHRP plus IPsec. So as we were discussing yesterday, the limitation of GRE is that it's by default it's point to point. But for example, if I have a site, I have a hub and spoke kind of architecture, all right, where I have multiple sites and one hub location. You can say let's a bank site. So it's a head office of that bank. The top one and the bottom ones are the spokes. So when I'm doing GRE, pure GRE, in fact, then I need to have a dedicated tunnels. For example, in this architecture, the upper one is hub and below are my spoke 1, 2, 3. In that case, I need to have a dedicated tunnel with each. So with this architecture, my hub will needs to have 3 virtual tunnel interfaces, right?
Yes.
Let's say the number of spokes are near to 10K, which basically means I need to have 10K virtual interfaces on my hub location, but it is not scalable, it's not feasible. So instead of this, what we can do, we can use MGRE instead of GRE. I will create a tunnel interface, and that tunnel interface will connect all the spokes with the hub. So only one tunnel interface I need. What I just need to change, I just need to change this mode from point to multi-point, because now this, if I'm looking from the hub perspective, this is my end point number 1 where the tunnel begins, and these are the other ones, 1, 2, 3, and so on. So single source for this tunnel, but multiple destinations, known as your MGRE. So what happens in MGRE, if I create a, let me draw a proper diagram. This is my hub location. Okay, let me take the same diagram. One sec. In this diagram, this is my hub location, okay, and the bottom ones are the spoke locations. With MGRE, you can only define source under your tunnel interface. How I used to configure an interface tunnel on hub, I'll say interface tunnel 1, IP address of the tunnel. Let's say I'm giving IP address is 172.16.1.1/24. Then I used to define tunnel source which would be still the same. In my case, is faster than 0 by 0. Then I used to define the tunnel destination. Okay. But when I'm doing point to point, I have a destination, which is the second endpoint of the tunnel. Can you tell me what would be the destination in this scenario? If I want to define a tunnel destination, what would be the tunnel destination? I'm doing this config on hub.
Okay. It should be multi-site.
Correct. So it's MGRE. So I cannot have a destination because there's only one option I can have, right? But I cannot put all the three here.
Yes.
So what we can do, instead of defining this tunnel destination, we can say tunnel mode GRE multi-point. Now your tunnel will start functioning in a multi-point environment, which simply means now your hub needs to learn about the spokes. What information he needs to have? Hub needs to have this information. For example, I'm doing an R2. Okay, so let me configure R2. R2 tunnel IP is 172.16.1.2. I need a mapping, right? And I'll say NBMA address, non-broadcast multi-access, basically your WAN IP. This address is 192.1.20.2. All right. Similarly, for R3, I will say the tunnel address is 1.3 and the NBM address is 30.3. Here I'll say tunnel address is 1.4. It's going to be 40.4. These red addresses are my WAN address. So we need some sort of mapping on R1. For example, let's say I will say on R1, if I want to reach a tunnel which has IP 192.168.1.2, the associated WAN address is 20.2. Because from the ISP perspective, only the WAN interfaces are routable on the internet, not the tunnel interfaces, right? ISP is aware of 192.1.20.2. If R1 sends any packet towards ISP, has a destination 172.16.1.2, then ISP will drop it because it's a private address, not routable on the internet. So from R1 perspective, let's say I have configured the MGRE and now I'm running EIGRP on top of it. If I do a show IP route EIGRP, these LAN networks, right? I will see next hop as the tunnel interface, correct? Or the NBMA. It's a question to you.
Sorry. What was the question?
I'm asking if assume I have successfully deployed MGRE and running EIGRP on top of it. And if I do a show IP route EIGRP on hub, what would be the next hop for the loopback addresses of my spokes?
It would be the next hop.
Yeah, that's the question. What would be the next hop? What is the IP? For example, if I'm doing Then what is the next stop I'm going to see on hub? Let me give you
It
options.
should be that 192.168.1.20.x 20.2.
You are running your tunnel like this, right? And EIGRP on the tunnel. What is the tunnel IP you have?
IP 172.16.1.2.
So you are going to learn about EIGRP routes from tunnel, right? So what would be the right next stop?
Okay. So,
It's going to
so
be
it should be 172. Yeah.
correct.
It should be 170.
Right, right. So it's going to be 172.16.1.2.
Okay.
Okay, that's correct. But now, since it's MGRE, right? It needs to have this mapping R2, because when R1 is building up a packet, it will build a packet with a data, the actual data, source and destination MAC, and the source IP. What is the source IP? Let's say the source IP. This is the actual packet I'm just demonstrating here, which is, and the destination IP is, let's say he wants to ping 2.1. Now about the EIGRP, where I'm running EIGRP, I'm running EIGRP on the tunnel. My tunnel source is 1.1. Okay, and tunnel destination is going to be, as you said, next stop would be 172.16.1.2. That's correct. So far so good. But I don't know, being an R1, I don't know where is 172.16.1.2. Who is 1.2? R2, R3, or R4? Because to encapsulate this packet inside your GRE, you need to have a GRE header. So GRE source, I know GRE source is going to be 192.1.10.1. This is what I have defined here. Okay, so that's fine. But what is going to be the GRE destination in the GRE header? So it's your original IP, this one. This is your GRE. So this is GRE source. What is the GRE destination? Means I need to know who is 172.16.1.2. I need to have this information, this mapping on R1. So for assume R1 has this mapping, what R1 will check, okay, who is 172.16.1.2? It's R2. And what is the NBMA address associated with it? It's 192.1.20.2. So he will put that information here. All right. That's how it completes the packet. So in short, we understand that R1 needs to have this mapping in order to determine where this next stop is actually associated with. Let me show you this thing. So there are two ways we can have this mapping. One, the non-preferred way is static, where you will be doing this mapping manually. Another, the better way, is dynamic. So you need a protocol for this. The protocol name is NHRP, which says next hop resolution protocol. Any question on this?
No, actually, don't.
Like router booting, just give it 2 minutes, then we'll start.
Okay. So I'm seeing there is only one tunnel interface. Okay.
We'll see. We'll configure it. As of now, these are blank. They don't have anything apart from the WAN piece. Now I can easily access. Okay, so first thing, this is my hub router. Okay, in the hub router, what I have configured so far is the routes. So I only have a default route going towards ISP. Same thing on all the devices. Interface address and just a default route. Nothing apart from this. So if I see now, let me try to ping. If I can ping the WAN IP is the NBMA address of R2. Let's see what is the IP address configured here. It's 20.1 which is configured. Okay, on this side I'm on R3. It's 30.1. Let's check on R4. It's 40.4. So let me change it to 40.1 to keep it same across all. Now let me try to ping the WAN IPs from hub. 20.1 is going fine. Let us check 30.1. It's there. Let us check 40.1. So all the WAN IPs are reachable, right? Which means the job of ISP is done. Now I want to run MGRE on it. So let us start with hub router. I will say interface tunnel 1. Before that, I'll show you this. No tunnel interface configured for now. Okay. Just a WAN IP and a loopback. Loopback is representing as a LAN network. So I'll say interface tunnel 1. IP address I'm going to use is 172.16.1.1. Tunnel source is going to be 192.1.10.1. Who is 10.1? My own IP is the tunnel source. I cannot define tunnel destination because it's MGRE, so I'll say tunnel mode GRE multi-point. Okay, now I have defined GRE multi-point, so I don't need to define tunnel destination here because I've already said it's multi-point.
Yes.
Okay, so I won't say tunnel destination. So that's all what we have configured for now. IP, source, and tunnel mode. Okay, as I explained, we need to have this mapping on R1. Let me show you if there's no mapping, what is going to happen then. So let us configure R2 first. So how I'm going to configure R2 is I will say interface tunnel 1, 172.16.1.2 is going to be R2 IP, tunnel source is fastness 0 by 1. Tunnel destination, sorry, 10.1.
10.1.
Okay. I am going to configure EIGRP as well. I will do it on hub as well. So I will say EIGRP and advertise my this subnet. Also, I'm advertising my LAN network, which is 192.168.2.0. This is on R2. On R3, tunnel IP is going to be 1.3. Source is 1.0. Destination remains the same. This 192.168.3.0 is going to change, and this one is going to same 172.16.1.0. This goes to R3, and R4 is going to be 1.4 is the R4 IP. 2.0 is my tunnel source. Destination remains the same, and this address is going to be 4.0. My LAN network on R4, but it is not going to bring the EIGRP up. Right? Because I don't know where to send the packet, even if there's a, okay, I'm not configured EIGRP, but even if I configure it, let us see. EIGRP showing up. Let me show you. Show route. Do show IP route EIGRP. Do show IP EIGRP neighbor. You see, it's showing you the queue count here, which simply means your neighborship is not fully up. Also, there is no route on the EIGRP. Nothing. Because the reason you have not defined the tunnel destination, you have just said tunnel mode is GRE multi-point. But where to send the EIGRP hello packets, we don't know. So this mapping doesn't exist as of now on R1. Because if the mapping exists, then only what R1 will do, R1 will encapsulate those packets in the GRE. As of now, R1 is aware about the tunnel. It doesn't know where is our destination. So let us configure this mapping on R1 first. So for that, you need a protocol known as NHRP. To activate NHRP, I will say IP NHRP network ID 1. You can give any number. Then you will say IP NHRP map. Map, I want to do a mapping, this mapping. Okay. This mapping I want to do. So I will say if I want to reach this tunnel IP, send the packet to this address. Same thing for all. So I'm mapping my tunnel IP with the NBMA address with the help of a protocol known as NHRP. And I'm doing it in a static way. So I will say IP NHRP map the tunnel IP. And the associated WAN IP. I have two more. Tunnel IP is 1.3 and it is configured on, okay, I did a mistake. I think it's 20.1. So I'll send now. It's 20.1. For the next one, it's 1.3 and 1.3 is configured on R3. Next guy is R4, which is 1.4. The WAN IP to reach 1.4 is 40.1. Same mapping I need to do on my spokes as well. So on the spokes, I need to say interface tunnel 1 IP NHRP network ID to activate it, to enable NHRP. Then you need to define your mapping IP NHRP map 192, oh sorry, 172.16.1.1 and the WAN IP associated as 10.1. I need to define it on all the spokes. So the complete configuration of the spokes is this thing. You just activated your NHRP. Okay, same thing on hub. Hub has 3 mappings. Still, my neighborship I don't see is up. All right, it's still down because this NHRP by default it carries only the unicast traffic, and EIGRP packets are multicast based. So the EIGRP packets are getting dropped. So to forward the multicast packet, I need to define a separate entry. Under the tunnel interface, I need to say IP NHRP multicast and the NBMA address. So on hub, I will say IP NHRP map multicast, which means if I'm receiving a multicast packet, send that packet to 20.2. It's 20.1 and 30.1 because I want to send those packets to all 4. I will define this on my hub. On spokes, I just need to send my NHRP packet to hub router. Now you see your neighborship is now up. There's no queue count. Also, I should be able to see the AHRP routes. Now all the routes are showing up. As we discussed at this point, right? What would be the next stop of your 2.0? So let's see this now. Where is 2.0? This guy, R2's loopback one. So this 2.0, what is my next stop? My next stop is 172.16.1.2. But who has this 1.2? Either R2, R3 or R4. Or we can say how to reach 1.2, which is the associated NBMA address with this. Because all I know is the next stop is 1.2 and exit interface is my tunnel 1. But it's a multi-point interface. So it needs to have a mapping with the actual WAN IP. This mapping. Right. So let me show you this mapping now, which we have configured manually. Do show IP NHR. Now it says if you want to reach 192.168.1.2, it is reachable via this NBMA address, which is 20.1. And you have configured this in a static way. So since it's a static, it's a manual mapping, which means it's never going to expire. There's no timeout for this mapping. Same goes, if you want to reach the tunnel interface address of R3, you need to send the packet to this NBMA address as your outer header, outer IP header. So you'll see dual IP encapsulation, right? One for your actual IP packet and another one is the GRE encapsulation. So GRE encapsulation will be based on this as a destination and himself as a source. So now if I want to ping from R1 to 2.1, I am able to. If I want to ping R3 and R4, Let's check the routes on spokes.
Oh, okay.
EIGRP route, right? So it is learning about only hub route. Why?
Yeah, only about because multicasting we did for only one router actually.
Correct. So for multicast reason, it is having only one neighbor
Yeah.
because I'm exchanging my multicast packet, which is EIGRP hellos with only hub. But there's a rule, a split horizon rule in EIGRP. What that rule says, let me clean up this. So that rule says on EIGRP, on your tunnel interface, the rule says if I'm learning some route, for example 2.0 via my tunnel interface, I'm not going to advertise the same route via the same interface to avoid potential loops. So in our case, R1 is learning about 2.0 on the tunnel interface, right? Via the tunnel interface.
Yes.
Learning it via tunnel. So it's not going to advertise the 2.0 to R3 and R4 via tunnel interface. That's the loop avoidance algorithm of EIGRP. Now to override this behavior, what we can do, we can go on R1 under the tunnel interface. You just simply know it. You say no IP split horizon EIGRP 1. 1 is your autonomous system number. Neighborship will get resynced. Now, if I go and I check the routes, I am seeing the routes of other spokes as well. Earlier, I was having only this guy, but now I'm learning about R4 and R3 as well via my hub. This is my tunnel interface address of my hub, but still, I only have one neighbor because I'm exchanging my EIGRP hellos with only hub. Okay, so if I want to ping 192.168, let's say 3.1 using my loopback one, I'm able to ping. And if I want to trace R3 loopback from R2, it is going via hub. So that is your spoke to spoke communication via hub. If I don't know it, if I keep it default, then it would be your hub to spoke communication. But this is your spoke to spoke via hub. It is done when there is a rare requirement of spokes to communicate with each other.
Okay.
So this is your MGRE with static LHR, but it's still not encrypted, still not secure. So what we need to do, we need to implement IPsec here. I'll say crypto ISAC policy 10 encryption, AES, authentication, pre-share, hash. I'm doing MD5 algorithm. Group 2, lifetime of this key is 3600 minutes. I will say crypto ISACAM key in clear text, so 0, Cisco, and address. Since I don't know the address of my spokes, so I can say 0000, or if I want, I can define the NBM address here of all the three spokes. As of now, I'm aware about the WAN IPs, assuming all the WAN IPs are statically configured. It's not allocated by the ISP, so I can define it. But if I don't have a static IPs on my spoke, I can say 000 as well. But it's kind of more vulnerable, so it's better to be specific. This is my phase one. Let me do my transform set, crypto IPsec transform set. Tset is the name. ESP I'm using ESPES and ESP SHA HMAC. Second last thing, crypto IPsec profile. I profile is the name I'm giving. I'm doing a set, transform set, Tset. I don't need to define peer or the interesting traffic because whatever is going through tunnel is interesting traffic. Peer I have already learned via an HRP. So last thing, just one last thing which says just apply this um, profile, this I profile to your tunnel interface. Okay, it's a tunnel protection IPsec profile and the profile name. Okay, let me do this config on R1, which is my hub. It took the commands. Now neighborship will go down because we know it's the receive packet is not IPsec packet. What I'll do next, I will configure this on spokes. So everything remains the same except the address which is going to be changed, right? All the things are the same. I did it on R2, neighborship on R2 came up, on R3 and R4. Let's check the neighborship status. Says all up. Show IP EHRP neighbor. Neighbors are up. Show IP route EHRP. Show crypto session to check my IPsec session. It's up and active with all. If I want to ping is up with my R1. ISAC amp is up. Let's check IPsec assay. And let's check for the encrypted packet directly. So it's encrypting all the packets. In every 5 seconds, I'm expecting to see the increase in count because of the AIGRP hellos. So the secure communication is now happening both the sides. Okay. So this is your static NHRP with IPsec. As I said, there's a better way. If you remember, we did all this mapping manually under the tunnel interface. So this is kind of not feasible when you have a lot of spokes. Let's say 10,000 to 20,000 spokes. Then you
Hmm.
cannot do this mapping, right?
Yes, of course.
So that's a scalability challenge with a static NHRP. So you have a better option. You will let NHRP do this mapping for you. That's known as the dynamic way of doing this same thing.